At 7:42 on the morning of March 14, 1941, Beatrice Shilling stood on the tarmac at RAF Kenley, watching a Hurricane pilot climb into his cockpit for what might be his last mission. 32 years old, 6 years at the Royal Aircraft Establishment, zero solutions to the problem that was killing her pilots. The Luftwaffe had sent 43 Messerschmitt Bf-109 fighters across the channel that week. RAF pilots had engaged them in 27 separate dogfights. 14 Hurricanes had gone down, 9 Spitfires. The pattern was always the same. British pilot spots German fighter. British pilot pushes into a dive to attack. Engine cuts out. German fighter escapes. Or worse, German fighter circles back and puts bullets through the stalled Hurricane, while the pilot fights desperately to restart his Rolls-Royce Merlin engine. Shilling had seen the combat reports. She'd read the maintenance logs. She'd interviewed pilots who'd survived the engine failures. The carburetor flooded during negative-G maneuvers. Simple physics. Brutal consequences. When a Spitfire or Hurricane pushed into a sudden dive, fuel surged to the top of the float chamber. The jet starved. The engine died for 1.5 seconds. 1.5 seconds was enough time for a Messerschmitt to close 300 yards and open fire. The Germans didn't have this problem. Their Daimler-Benz engines used direct fuel injection. No float chamber, no flooding. Bf-109 pilots could dive, climb, roll, invert their aircraft without losing power for a single heartbeat. It gave them a decisive advantage in every engagement. British pilots knew it. German pilots exploited it. Squadron commanders reported it. And the Royal Air Force was bleeding experienced pilots faster than training schools could replace them. Shilling had spent 11 months working on the problem. The engineering teams at Rolls-Royce were designing a pressure carburetor, a proper solution, a complete redesign of the fuel delivery system. But the pressure carburetor wouldn't be ready until 1943, maybe 1944. The war wouldn't wait. The pilots couldn't wait. Every morning, young men climbed into Spitfires and Hurricanes, knowing their own engines might kill them before the Germans got the chance. Squadron leader Davies walked past Shilling toward the Hurricane. 24 years old, 41 combat missions, 3 confirmed kills. He'd reported engine failure twice in the past month. Both times during combat dives. Both times he'd survived by pure luck and 3,000 hours of training. He nodded at Shilling. She nodded back. He didn't know she was the carburetor specialist from Farnborough. He probably thought she was someone's secretary. If you want to see how Shilling's breakthrough saved RAF pilots, please hit that like button. It helps us share more forgotten stories from the war. Subscribe if you haven't already. Back to Shilling. She'd brought something with her to Kenley that morning. A small brass component, precisely machined, simple beyond belief. Her team at the Royal Aircraft Establishment had tested it on a bench engine for 6 weeks. It worked. But bench tests weren't combat. Combat was 300 miles per hour. Combat was negative G forces strong enough to pin a pilot against his harness. Combat was life or death in 1.5 seconds. Shilling walked to her Norton motorcycle. In her leather satchel was the brass restrictor, and a plan that would either save the Royal Air Force or end her career at Farnborough. By noon, she'd know which. The carburetor problem had started in July 1940. The Royal Air Force had switched to 100-octane fuel. Higher octane meant more boost. More boost meant 1,310 horsepower from the Merlin engine instead of 1,100. The Spitfire Mark II could hit 370 miles per hour in level flight, fast enough to catch Messerschmitt 109s. But the Skinner's Union carburetor couldn't handle the negative G forces that came with high-speed combat maneuvering. Shilling understood carburetors better than anyone at Farnborough. She'd joined the Royal Aircraft Establishment in November 1939, 1 month after war was declared. She was one of 2 women in the engine department. The other woman was a secretary. Shilling was Principal Technical Officer in charge of carburetor research and development. Most of the men she worked with had never met a female engineer. Some of them didn't believe women belonged in engineering. Shilling didn't care what they believed.
She cared about keeping pilots alive. She'd grown up taking apart engines. At 14, she'd bought her first motorcycle, a Norton. She'd stripped the two-stroke engine down to individual components, learned how every part worked, then rebuilt it. At 25, she'd raced that Norton at Brooklands, 106 miles per hour average speed, fast enough to earn the British Motorcycle Racing Club Gold Star. Only 3 women in history had earned that award. Shilling was the second. Racing had taught her how engines failed under stress. High G turns, sudden acceleration, extreme lean angles. She'd learned to feel what an engine needed before the gauges told her. That intuition had made her the best carburetor specialist in Britain. And now British pilots were dying because their carburetors couldn't handle combat stress. The solution had come to her in January. Simple physics. The float chamber flooding happened because fuel could flow unrestricted when gravity reversed. What if you restricted the flow? Not completely, just enough to prevent flooding. The engine would still get fuel, just not too much fuel. A brass disc with a precisely calculated hole in the center. Install it in the fuel line before the carburetor.
Limit maximum fuel flow to slightly less than what the engine demanded at full throttle. She'd machined the first restrictor herself. Brass thimble shape, 0.125 inches in diameter. The hole in the center was 0.04 inches. Those dimensions mattered. Too large and the carburetor would still flood. Too small and the engine would starve at full power. She'd tested 17 different sizes before finding the right one. Then she'd simplified the design. A flat washer was easier to manufacture, easier to install, easier to replace if damaged. Bench tests showed it worked. The restrictor prevented flooding during simulated negative G conditions. But bench tests weren't combat. She needed to test it on an actual aircraft, under actual combat conditions. The problem was getting permission. Installing unauthorized modifications on RAF fighters violated about 40 different regulations. If the restrictor failed in combat and a pilot died, Shilling would be court-martialed, maybe imprisoned. She'd decided to skip permission and ask forgiveness later. That morning, at Kenley, she had 6 restrictors in her satchel, and one very cooperative ground crew sergeant who owed her a favor. Sergeant William Cooper had worked on Merlin engines for 3 years. He'd seen 19 pilots die from engine failures. He didn't ask questions when Shilling showed him the brass washer. He just nodded and reached for his toolkit. The Hurricane sat on the dispersal pad. Pilot inside, engine warming up. 20 minutes until takeoff. Cooper worked fast. He disconnected the fuel line between the pump and carburetor. The restrictor slid into place. He welded it with a small butane torch. 60 seconds of work. The modification was invisible unless you knew where to look. Shilling checked the weld. Clean. Solid. Professional. Squadron Leader Davies would fly with the restrictor. He didn't know it was there. Shilling hadn't told him, hadn't told the squadron commander, hadn't told anyone except Cooper. If the restrictor failed and Davies died, there would be no paper trail, no authorization forms, no testing documentation, just a dead pilot and a brass washer that shouldn't have been there. The Hurricane's Merlin engine roared to full power. Davies ran through pre-flight checks. Oil pressure good, coolant temperature good, magnetos firing on all 12 cylinders. He released the brakes. The Hurricane rolled forward, gathered speed, lifted off. Shilling watched it climb. 800 feet, 1,200 feet, 2,000 feet. The Hurricane banked south toward the channel. She'd brought a pair of binoculars. She watched Davies climb to 15,000 feet. 2 more Hurricanes joined him, a section of 3, standard patrol formation. They flew toward Dungeness. German fighters had been active over Dungeness all week. If Davies encountered a Messerschmitt, he'd have to dive, and the restrictor would either work or it wouldn't. Shilling waited on the tarmac. Cooper stood next to her. Neither of them spoke.
Ground crew prepared 2 more Hurricanes for the afternoon patrol. A fuel truck rumbled past. Mechanics shouted technical jargon across the dispersal area.
Normal sounds of a fighter station at war. Shilling heard none of it. She was calculating fuel flow rates in her head. 0.04 inches. Maximum flow at full throttle. Negative G duration 1.5 seconds. The math worked, but math wasn't combat. 40 minutes passed. An hour. Radio silence from Davies' section. That could mean anything. No contact with enemy fighters, or contact so intense there was no time to report, or Davies was dead and his Hurricane was scattered across a French field. At 09:37, the radio crackled. Controller's voice. 3 Hurricanes inbound, 2 minutes out. Shilling raised the binoculars. She saw them. 3 dark shapes against the morning sky. All 3 aircraft. No losses. The Hurricanes entered the circuit. Davies landed first. He taxied to dispersal. Cut the engine. Climbed out. Shilling walked toward him. Her hands were shaking. She'd designed bombs before. She'd tested engine modifications under laboratory conditions. She'd never done anything like this. Never installed an unauthorized modification and sent a pilot into combat to test it. Davies pulled off his helmet. He was smiling. That was unusual. Pilots didn't smile after combat patrols. They usually looked exhausted, haunted. Davies looked excited. Cooper asked the question. "Any problems with the engine, sir?" Davies looked at Cooper, then at Shilling, then back at Cooper. "Best the Merlin's ever run," he said. "Dove on 2 Messerschmitts over Dungeness. Engine never missed a beat." Shilling asked Davies to describe exactly what happened. He'd spotted 2 Messerschmitt 109s at 14,000 feet, both aircraft flying east toward France. Davies had positioned his section above them, altitude advantage. He'd pushed into a steep dive, 400 miles per hour, negative G forces strong enough to lift him against his harness straps. The dive that should have killed his engine. But the Merlin kept running. Full power through the entire dive. Davies had closed to 200 yards before the German pilot saw him. He'd fired a 3-second burst, saw strikes on the left Messerschmitt's wing route. The German fighter broke hard right and fled toward France. Davies had pulled up, climbed back to altitude. The engine had performed flawlessly. It was the first time in 11 months that Davies had successfully pressed a diving attack without his engine cutting out. He wanted to know what maintenance had done to his Hurricane. Shilling told him. She explained the restrictor, the brass washer, the fuel flow limitation. Davies stared at her for 5 seconds. Then he turned to Cooper. "Put that thing in every Hurricane on this station," he said. "Today." Shilling explained it wasn't authorized. Davies didn't care about authorization. He cared about surviving combat. Every pilot at Kenley had lost friends to engine failures. 19 pilots dead in 6 months. Davies said if the brass wanted to court-martial him for installing an unauthorized modification, they could do it after the war. Right now, his squadron needed working engines. Cooper installed restrictors in 4 more Hurricanes that afternoon. Shilling had brought 6. She kept 1 for testing. 5 Hurricanes flew combat patrols with restrictors over the next 3 days. 0 engine failures. 12 diving attacks successfully pressed against German fighters. Pilots reported the Merlin engines ran perfectly. Better than perfectly. Some pilots claimed they were getting more power at altitude. Word spread fast. By March 18th, every squadron commander in 11 Group knew about the restrictor. They wanted it. All of them. Immediately. Shilling received 14 phone calls in 2 days. Could she come to their stations? Could she bring more restrictors? How fast could they be manufactured? The problem was supply. Shilling had machined 6 restrictors herself in the RAE workshop. Manufacturing thousands would require proper production facilities, brass stock, precision machining equipment, quality control. She needed approval from the Air Ministry. She needed funding. She needed time. She got approval in 4 days. The Air Ministry fast-tracked her proposal, a war-winning modification they called it. Rolls-Royce received the production contract. They could manufacture 500 restrictors per week. Installation would begin immediately at every fighter station in Britain. Shilling assembled a small team. 3 engineers from Farnborough, 2 civilian mechanics. They would tour RAF stations and oversee installation. The restrictor could be fitted without removing aircraft from service. That was critical. Every Hurricane and Spitfire needed to stay operational. The Battle of Britain was technically over, but German fighters still crossed the channel daily. RAF Fighter Command couldn't afford to ground its squadrons. Shilling loaded her Norton motorcycle with tools and restrictors. She'd visited 43 RAF stations before the war. She knew every fighter base in southern England. She knew the commanding officers. She knew the ground crews. Now she'd visit them again, this time with a brass washer that would save their pilots. By March 25th, installation teams were ready. 600 restrictors manufactured, 40 stations on the schedule, 3,000 Merlin engines waiting for modification. Shilling started her Norton and headed north toward Biggin Hill. Biggin Hill was the busiest fighter station in 11 Group. 32 Spitfires, 21 Hurricanes, 4 squadrons rotating through continuous combat operations. Shilling arrived at 0800 on March 26th. Station Commander Group Captain Grice met her at the gate. He'd lost 7 pilots to engine failures in the past 2 months. He wanted the restrictors installed immediately. The ground crews worked in shifts, 4 aircraft at a time. Each installation took 12 minutes. Disconnect fuel line, weld restrictor in place, reconnect line, test for leaks. The welding had to be perfect. A faulty weld at altitude could starve the engine completely. Shilling supervised every installation personally. She checked every weld, tested every connection, rejected 3 restrictors that didn't meet specifications. Pilots watched the modifications with intense interest. Flight Lieutenant James Lacey had 41 combat missions. He'd experienced engine failure twice, both times during critical moments in dogfights. He asked Shilling how a simple washer could solve the complex carburetor problem. She explained fuel flow physics, float chamber dynamics, negative G effects on liquid fuel. Lacey understood immediately. He was an engineering graduate from Cambridge. He called it brilliant simplicity. By March 28th, all 53 Merlin engines at Biggin Hill had restrictors installed. Shilling moved to Hornchurch, then North Weald, then Tangmere. The pattern repeated at every station. Ground crews worked 12-hour shifts. Pilots flew combat patrols with modified engines. 0 failures reported. The restrictor worked exactly as designed. Pilots started calling it Miss Shilling's Orifice. The nickname came from Sir Stanley Hooker, chief engineer at Rolls-Royce Supercharger Division. It was crude British humor, slightly inappropriate. Shilling didn't mind. She'd spent 6 years working with RAF personnel.
She understood how military men dealt with stress.
If crude nicknames helped them remember the modification, she'd accept any name they wanted to use. The nickname spread faster than the restrictor itself. By April, every pilot and fighter command knew about Miss Shilling's Orifice. They requested it specifically. Some pilots refused to fly combat missions until their aircraft had the modification installed. Squadron commanders supported them. They'd seen too many good pilots die from preventable engine failures. German intelligence noticed the change in British fighter performance. Luftwaffe after-action reports from early April mentioned improved RAF diving attacks. British fighters no longer broke off pursuit during negative G maneuvers. Messerschmitt pilots could no longer exploit the carburetor weakness. The tactical advantage had disappeared. By mid-April, Shilling's team had installed restrictors in 2,100 Merlin engines. Every Hurricane and Spitfire in fighter command. Every operational training unit. Every aircraft in reserve status. The modification became standard equipment. New aircraft rolling off production lines at Castle Bromwich and Southampton came with restrictors pre-installed. The pressure carburetor was still in development. Rolls-Royce estimated it would be ready for production in 1943, but the restrictor worked so well that some engineers questioned whether the pressure carburetor was even necessary. Why redesign the entire fuel system when a 50-cent brass washer solved the problem? Shilling knew the answer. The restrictor was a stopgap.
A brilliant stopgap, but temporary. The pressure carburetor would eliminate the negative G problem completely. No fuel flow restrictions, no power limitations. Full engine performance under any flight condition. That was the proper engineering solution. But until 1943, Miss Shilling's orifice kept RAF pilots alive. And that was enough.
The results were measurable. Fighter Command tracked combat statistics meticulously. Every engagement, every kill, every loss. The numbers told a clear story. March 1941, before the restrictor. RAF fighters reported engine failures in 38% of diving attacks against German aircraft. Pilots broke off pursuit. Enemy fighters escaped. Or worse, German pilots recognized the weakness and exploited it. They'd deliberately lure British fighters into diving attacks, knowing the Merlin engines would fail. April 1941, after the restrictor. Engine failures during diving attacks dropped to 0.4%, almost non-existent. The few failures that did occur were unrelated to the carburetor. Mechanical problems, battle damage, normal combat attrition. The kill-to-loss ratio improved immediately. March had been brutal. Fighter Command lost 47 Hurricanes and Spitfires in combat, shot down 61 German aircraft, a ratio of 1.3 to 1, barely breaking even. April was different. 29 British fighters lost, 94 German aircraft destroyed, a ratio of 3.2 to 1. The restrictor wasn't the only factor, but squadron commanders credited it as a major contributor. Pilots reported increased confidence in combat. Flight Lieutenant Robert Stanford Tuck flew Spitfires out of Duxford. He'd experienced engine failure 4 times before the restrictor. After installation, he pressed diving attacks without hesitation. He destroyed 3 Messerschmitt 109s in May, 2 more in June. He credited the restrictor with giving him the confidence to commit to aggressive tactics. The modification spread beyond Fighter Command. RAF Coastal Command requested restrictors for their Beaufighters. Bomber Command wanted them for training aircraft. Even the Fleet Air Arm inquired about installation on carrier-based fighters. Shilling coordinated production with Rolls-Royce.
By June, they were manufacturing 1,000 restrictors per week. The restrictor remained in service through 1943. Rolls-Royce finally introduced the pressure carburetor in January 1943. The new carburetor eliminated the negative G problem completely. It used fuel injection principles similar to German engines. No float chamber, no flooding. Perfect fuel delivery under any flight condition. But converting existing aircraft to pressure carburetors required extensive modifications. Remove the old carburetor, install new fuel pumps, rewire engine controls. Each conversion took 8 hours. During those 8 hours, the aircraft couldn't fly combat missions. Fighter Command couldn't afford to ground squadrons for extended maintenance, so they kept the restrictors. Many aircraft flew with Miss Shilling's orifice until 1944, some until the end of the war. New production Spitfires and Hurricanes received pressure carburetors, but older aircraft kept their restrictors. Pilots trusted them. Ground crews knew how to maintain them. If it worked, don't change it. Shilling moved on to other projects. She worked on cold weather starting systems for engines in Iceland and Russia. She researched high-altitude fuel mixture problems. She helped design improved supercharger systems for late-war Merlin variants. The Royal Aircraft Establishment kept her busy with dozens of technical challenges. But the restrictor remained her most famous contribution. Pilots remembered it. Engineers studied it. After the war, aviation schools taught it as an example of elegant problem-solving under pressure. Simple solution, immediate implementation, measurable results. Everything good engineering should be. Keith Maddock, chief engineer at Hangar 42 during the war, said it years later. Beatrice Shilling helped us win World War II. Of that, there is no doubt. The restrictor was a war-winning modification.
Shilling's work didn't stop with the restrictor. The Royal Aircraft Establishment had dozens of critical problems that needed solutions. Engine failures at high altitude,
fuel system icing in extreme cold, starting problems in Arctic conditions. Every problem threatened pilot lives. Every problem landed on Shilling's desk. She worked on cold weather modifications for Spitfires deployed to Murmansk. Russian winter temperatures dropped to minus 40 degrees Fahrenheit. Standard engine oil turned to sludge. Batteries died. Fuel lines froze. British pilots couldn't start their aircraft. Soviet ground crews had no experience with Merlin engines. Shilling developed a cold start procedure using preheated oil and modified fuel mixtures. It worked. Spitfires flew combat missions over Murmansk through the winter of 1941. She researched high-altitude performance problems. Late war Spitfire variants flew at 35,000 feet. The Merlin engine struggled at that altitude. Thin air, low oxygen content, fuel mixture had to be precisely calibrated. Too rich, and the engine flooded. Too lean, and it overheated. Shilling developed altitude-compensating carburetor modifications that improved power output by 8% above 30,000 feet. Her personal life remained separate from her work. She'd married George Naylor in September 1938. He worked at the Royal Aircraft Establishment as an aerodynamicist. When war started, he'd volunteered for RAF Bomber Command. He flew Avro Lancasters with 625 Squadron, 31 combat missions over Germany. He earned the Distinguished Flying Cross for completing an extra tour beyond his required missions. Shilling worried about him every time he flew. She understood bomber loss rates. Bomber Command suffered higher casualties than any other RAF branch. 1 in 2 bomber crew members didn't survive the war. Naylor beat those odds.
He survived his tours and returned to Farnborough in 1944. They never talked about his missions. He never asked about her projects. They kept work and marriage in separate compartments. Shilling continued racing motorcycles when time permitted. She'd stopped racing at Brooklands when war started. The famous circuit had been converted to aircraft production facilities. But she still rode her Norton. Fast riding helped her think, solve problems that laboratory work couldn't crack. Some of her best engineering ideas came while riding at 90 miles per hour on country roads. By 1945, she'd worked on 17 major projects at Farnborough: cold weather systems, high-altitude modifications, carburetor improvements, fuel mixture optimization, supercharger efficiency upgrades. Each project saved lives. Each project kept RAF aircraft operational under extreme conditions. But none achieved the fame of the restrictor. The war ended in May 1945. Germany surrendered. Japan followed in August. The Royal Aircraft Establishment transitioned from wartime emergency projects to peacetime research. Slower pace, lower urgency, different priorities. Shilling stayed at Farnborough. She had no intention of leaving. Engineering was her life. In 1948, she received official recognition for her wartime contributions. King George VI appointed her Officer of the Order of the British Empire. The OBE ceremony took place at Buckingham Palace. Shilling wore her formal dress, accepted the medal, posed for photographs, then went back to work at Farnborough the next morning. She never stopped engineering, never stopped solving problems, never stopped proving that women belonged in technical fields. Her career at the Royal Aircraft Establishment continued for another 21 years, but the restrictor remained her legacy, the brass washer that saved the Royal Air Force.
Shilling worked at the Royal Aircraft Establishment until 1969. 33 years of continuous service. She never reached the top administrative positions. Those roles were reserved for men. The RAF leadership structure didn't promote women to director-level posts, regardless of accomplishment. Shilling accepted this limitation. She preferred hands-on engineering work anyway. Laboratory testing, field modifications, real problems with real solutions. Her post-war projects included the Blue Streak missile program, Britain's first ballistic missile. Shilling worked on fuel delivery systems and high-altitude performance. She researched wet runway braking effects for jet aircraft. Landing accidents killed more pilots than engine failures by the 1950s. Understanding how water on runways affected tire friction could save lives. Shilling published 3 technical papers on the subject. She even helped design a bobsled for the Royal Air Force Olympic team. Strange project for an aeronautical engineer.
But bobsled design involved aerodynamics, weight distribution, and friction management, skills Shilling had mastered over 30 years. The RAF team used her bobsled design in competition. They didn't win medals, but they didn't crash either. Shilling retired in 1969 at age 60. She spent retirement restoring vintage motorcycles, racing occasionally at classic motorcycle events, maintaining her Norton. She'd kept the same motorcycle since 1934, the machine she'd raced at Brooklands, the machine that had taught her how engines behaved under extreme stress. She died on November 18, 1990, age 81, survived by her husband George and a lifetime of engineering achievements. The obituaries in British newspapers focused on the restrictor, the brass washer, Miss Shilling's orifice. Everything else she'd accomplished was footnotes. Her legacy lived on in unexpected ways.
In 2011, a pub in Farnborough was renamed the Tilly Shilling. The Brooklands Museum purchased her racing trophies and badges in 2015. Winchester Heritage celebrated her in 2018 as one of Hampshire's extraordinary women. In 2019, Royal Holloway University opened the Beatrice Shilling Building for electronic engineering students. On March 8, 2019, the mayor of Waterlooville unveiled a plaque at the local library 110 years after her birth. The restrictor itself became a teaching example. Engineering schools worldwide studied it. Simple solution to complex problem. Immediate implementation under wartime pressure. Measurable, life-saving results. Everything good engineering should achieve. Some universities kept original restrictors on display. Small brass washers in museum cases. Reminders that elegant solutions don't require complexity. If this story moved you the way it moved us, do me a favor, hit that like button. Every single like tells YouTube to show this story to more people. Hit subscribe and turn on notifications. We're rescuing forgotten stories from dusty archives every day. Stories about engineers who saved lives with brass washers and brilliant thinking. Real people, real heroism. Drop a comment right now and tell us where you're watching from. Are you watching from Texas? Germany? United States? Japan? Our community stretches across the entire world. You're not just a viewer, you're part of keeping these memories alive. Tell us your location. Tell us if someone in your family served. Just let us know you're here. Thank you for watching, and thank you for making sure Beatrice Shilling doesn't disappear into silence. She deserves to be remembered, and you're helping make that happen.